Good evening, students. This lecture is my continuation of the previous lecture, which was about the analog input output. So, as we've covered analog input output, the next part is analog isolation. Now, for what purpose isolation is needed? What is the need of isolation? First, we have to understand this thing. Analog isolation is very much needed in the DEC system, as this DEC system is basically used in industrial applications for any automotive process, in any industrial process. So in that case, once all the hardware components in the DEC system, all the hardware components along with the DEC system is connected, then through this DEC system it is further communicated to the computer or the laptop, from where the monitoring or controlling operation can be done. So for that purpose, it should not harm the computer, it should not harm the DEC system. For that purpose, the isolation is very much needed. So analog isolation is divided into transformer. It can be done by magnetic isolation, it can be done through optocouplers, which can be used in AC and DC circuits, and third is buffer or isolation amplifiers, or other name is voltage follower circuits. So analog isolation is basically used in a DEC system as it is used for many applications, like in for medical instruments. In medical instruments, it is basically used to monitor the health of the patient or to analyze certain tests through those instruments. So for that purpose, if there is any high voltage or transients at the source side, so it can harm the electronic equipments or the machines or the electronic instruments which are used for the measurement purpose for health monitoring of the patients in the medical field. So in that case, it can harm the certain high voltage spikes or transients, can harm the instrument, as well as through the instrument we are monitoring the health of the patient. So it somehow harm the patient also, or can cause certain accidents there itself. For that purpose, the analog isolation is very much needed. Like as today we are seeing that from corona, which is an epidemic disease, and right now we are not finding any preventive measures for it, or any vaccine or any vaccine or medicines to cure that disease. So the isolation is the only thing, or social distancing is only thing that can stop this chain. So in the similar manner, this analog isolation is very much needed. So it isolates the input side and the output side, and due to which whatever be if any voltage spike or high voltage transient comes at the input side, so it will not going to harm the output side or the instruments connected across the power source. So for that purpose, the isolation is very much needed. I hope this analog isolation is now very much clear to you. Now we further move to how does this isolation can be done. So the isolation can be done through magnetically with the help of the transformer. Obviously it can be used in the AC circuits, and the second method for the isolation is optocouplers. Optocouplers can be used in AC and DC circuits. And the third type of isolation is your voltage follower circuit or isolation amplifiers. So firstly I will discuss, as it is essential for the to protect the user and equipment from contact with high voltages. For that purpose, isolation is very much needed in the medical field, in the industrial automation field, to control the process and all the equipments connected across the power supply. So firstly I will discuss the magnetic isolation circuit. Now magnetic isolation circuit, in the magnetic isolation circuit you can see there is voltage source, AC voltage source, and this voltage source has been isolated at the different ground terminal. This is known as ground 1 terminal, right? So it is at different ground potential. And then there is the transformer which is used for the isolation circuit for just transforming the voltage from primary side to the secondary side with the help of the magnetic coupling. Now this is also kept in the electrically isolated circuit, as it is also kept in the isolation. And then the third output which we are getting, this output is further being isolated with the help of the differential amplifier, so that if the output is low, so that output can further be can further amplified and then can further be used or connected to another instrument. And this is at the separate ground potential. This is at separate ground potential. So output of this transformer is given to the amplifier or the differential amplifier circuit. So differential amplifier circuit or the amplifier circuit is also again kept into the isolation chamber and at different ground potential. So input side and output side are kept at different ground, so that we can protect our instrument which is connected at the output side, and also we can protect from any ground faults which is occurring in the system. So that's why they are kept at the separate ground potential. So if any voltage spikes or transients occur, then that can be eliminated here itself, right? That can be eliminated here itself. It cannot further move towards this circuit and cannot pass towards the output circuit. That's why we have isolated whole process. Input side is isolated, then the transformer which is used for the isolation purpose, it is just transforming the voltage at the primary side to the secondary side through the magnetic coupling, and whatever be the secondary voltage produced here, it can further being can further be given to the amplifier circuit, and it is isolated again at different ground potential, so that to protect it from the ground faults and other miserable conditions. So this is the magnetic isolation circuit, and this is very much useful for the protection purpose in the for analog isolation purpose for in the DEC system. Now next type of isolation which is generally used is the optocoupler. So optocoupler is the circuit for the optocoupler is this. So here we are using the LED. At the input side we are using the LED. Now once the voltage source connected here, so the LED will start blink. When the LED start glow, at that time the light through this light there is the this is the photo transistor. Through this light, the photo transistor basically detect this light, and through this light it will start getting conducting. So once this light will be on, so then it starts conducting and the output will be produced here. So here you can see that through the optocoupler, again the isolation barrier is given. So the signal is being electrically isolated, right? So what is happening here? The input voltage, whatever being given here, and at the voltage when the LED starts glowing, so through the light medium, through the light is traveling from the input side to the output side, due to which the photo transistor starts conducting and the output voltage is the same voltage which is appearing at the input side. So now we can see this optocoupler can be used for the digital input output isolation as well as for analog input output isolation. Now how it can work for the digital input output isolation? If digital input output isolation means it can work as a switch. So when the off condition is there, then both the LED as well as photo transistor will remain in the off condition, right? This is for the DC, it will be working on the DC, right? Now when the input voltage is given, the LED will glow. Once the LED will glow, then this LED light will this light will be transmitted and detected by the photo transistor, and then the current will start flow in the photo transistor, which so the output voltage can be taken across the terminal. So this will be on, then this will be on. If this will be, otherwise it will remain in off condition. So this is this type of protection can also be used in the digital input output isolation also. Optocouplers are mainly used for the digital input output isolation also. For analog also it can be used. Now for the analog input, if the for analog input, if we want to as the current measurement will depend on the intensity of the light, right? If the intensity of the light can be controlled by connecting the resistor or potentiometer across, or variable resistance across it, and if we are moving the variable resistance, then the current can be controlled, due to which the intensity will be intensity of this LED will going to be changed. If the intensity of that LED will going to change, that will be taken up, or that will be sensed by the photo transistor, and then the output will be here. If the change in the voltage, or if the change in this value will be very high, if the analog input change in the analog input value is very fluctuating, in that case the LED in that case the transmission rate will be slow by the LED, because the LED blinking will be depending on the change of the current, right? So as the blinking will be slow, or the blinking will be light, or so the light transmitted and detected by this, and then the output voltage will be given just proportional to that value, will be the slow process when the analog input is very much high, when there will be high change in the analog input value, right? So that's why this is generally used for the optocouplers, are mostly used for the digital input output isolation purpose. So that is just the disadvantage. And sometimes the due to the temperature, as the LEDs are quite sensitive for the temperature, so at times due to overheating, the LED LED will get blow off, and LED wear can be a disadvantage for this purpose when we are talking about analog input output isolation, right? So because in analog input, certain times the value will be changing. So value will be changing. So at that time there will be certain slow transmission, or slow detecting rate, due to which at times there will be certain problems. So this is just a small disadvantage of using this opto coupler or the photo transistor there. And for the AC circuits, we can use the photo triax or photo SCR there along with your LEDs. So this is all for the isolation purpose that optocouplers used, and the magnetic isolation circuit. And the third one is your buffer or the isolation amplifiers. So isolation amplifiers are what? Isolation amplifiers are just the voltage follower circuit. Whatever be the input voltage, as the whatever be the input voltage, it's the same will be available at the output side. And voltage follower circuit is generally used in the sample hold circuit before ADC, so that it is used for just for the isolation for the ADC, that when the input is going to the ADC, it will not going to fluctuate, right? In the during this, when the conversion process starts, once the conversion process will be over, then the next value will be coming through the sample and hold circuit to the ADC. So for ADC for ADC isolation, we go for the isolation amplifier or the voltage follower circuit, which is nothing but a differential amplifier also, where the output voltage is following the input voltage. The same principle is for the transformer, where through the magnetic coupling, we are just following the output voltage is following the input voltage. And similarly, in the optocoupler case, the output voltage is following the input voltage. Again, the same thing. If there is any change in the input voltage, that will be affecting the current will be changing across through LED, and due to the current change, the intensity of the light will be changing. Accordingly, the light detected by the photodiode here, phototransistor here, so accordingly the output voltage will be there. So electrical signal is traveling here through the medium of light, right? So this optocoupler has the very has an advantage of it is very much immune to electrical noise and magnetic circuits. So magnetically and electrically it is highly immune to noise. So that is the basically advantage for the optocoupler circuits. That's why it is very much used for the isolation purpose in analog input output as well as for digital input output isolation, because it can work as a switch also, either on or off condition. Generally it remains in off condition. When the input voltage is given an LED glow, then it will be in on condition, and that will be reflected at the output side also. So this is all about the analog isolation. So analog isolation is done analog isolation is done just to isolate the DEC system to work in the harsh environment, to control any process and monitor any process in the harsh environment, and also to protect the operator working in that console room with the computers from any hazardous voltages, spikes or transient condition. For that purpose only analog isolation as well as digital isolation is used. Now in the next lecture I will discuss about the multiplexing and then the digital isolation, then the analog output. So we discussed about analog input. Next is your analog isolation. After that I will discuss about the analog output, and then we will move towards the digital input output isolation. Thank you.